Hello, I'm Neeraj. So now I will explain how we can use one-shot strategies with LLM RAG based system. In previous tutorial, I had explained about zero-shot strategies, like how we can use some zero-shot strategies, different kind of zero-shot strategies with uh, large language models based RAG. But here we are in better situation because in zero-shot strategies we had no information about the targeted domain or targeted context either in the form of our collections or either with the prompt. But here we are little advanced. We have at least one information, means single example we have with our prompt which can guide the system to get the correct answer. So in general, one-shot learning refers to the model's ability to perform a task by seeing only one example. The model uses this single example as a reference to understand the task better and generate the appropriate response. So this is the concept. So the prompt includes the specific examples that demonstrate the how task should be performed. So this is the main things. So this is called as learning from example also. The model uses single examples to learn, for example, how to apply the task's requirement to the new input. Because in our collection part, we don't have such kind of domain or contextual information. So only example can help. So how to do this and what is the architecture? And once you have the one shot related thing, I am 100% confident that we can develop few sort and some more advanced architectures. So here also I have used the knowledge graph and hypergraph. We just combine knowledge graph and hypergraph based techniques with one shot. The main reason is we are assuming that we are not dealing with simple system. We are dealing with complex data. So as usual, we will first extract the knowledge graph triplets with the help of LLM. For simplicity, we are using LLM. You can use your own techniques. After that, we have a graph triplets. We apply some text embedding strategies to convert the knowledge graph triplets into vector vector data format and store it into vector database. We have used ChromaDB here. So this is your offline part. So this is complete because it generally takes a lot of time. Now your online system starts from here. So here you have some context information about your query and you provide that context, you embed your context informations with a query, and then after that again you have three approaches. Either extract triplets from the query, query means this combination, extract more meaningful relations from this combination, or use the complete query text as it is with this combination, apply text embedding and query it here. Now the scenario is like you have a data, for example you have a data related to beer. In this example, in our case, I have taken the example sample data, private data as a data related to beer which lives in non-polar environment. So all informations related to beer is available which lives in the non-icy, non-polar environment. Now here we wanted to know about the body physics or some body structure or some outlook about a polar bear. So here I had just provided one contextual information that polar bear is living in some polar area, Arctic area. So that informations we added with our questions, and after that we embed the text and file the query. So once we fire the query, as our data is not related to polar bear, but it will give some nearest informations regarding the body structure of the bear. So here you will not get more information. Maybe sometimes you may get little more information, but generally you will not get information. So here your data will be similar to like a zero sort kind of data. But here you will get the, when you file the updated prompt with this data and pass it through the LLM, then the data part will guide the large language model to find the appropriate things. But this updated prompt, which contains the updated contextual informations, will directly guide that how to pinpoint to reach the exact answer, and that's why you will get a better answer for your question. So this is the scenario. And if you want from one sort to two sort, three sort, few sort, you can increase this context. So now we will see that how it is possible in our scenario and how we can write the code for this. So here we have a simple document which contains beer related information downloaded from Wikipedia. We have a knowledge graph triplets. I already explained in previous tutorials how to extract these knowledge graph triplets from the given documents. Once we have a knowledge graph triplets, we will simplify the knowledge graph triplets like a text fragments by removing the comma through the some space, so that it will look like bears use shelters kind of things. After that, we will prepare a database, vector database. So we will use the ChromaDB persistent client. But before going into the detail, I will explain that I have used the offline trick. I have used the offline setting to run the entire system. For that, I have used the Olama to just download the Olama package to get the large language model libraries, large language models, trained models. I have used this GitHub site and downloaded the Llama 3 model. You can use any multiple number of models. Just run this code, it will automatically download this to Llama directory. And for text embeddings, I have used the BERT large text embedding. For that, use the MXBI embedding large. Just run this code, it will automatically download to your system. Once it is done, install the ChromaDB by using pip install ChromaDB. Once it is done, just to create the database. So I have just used the simple full address system. You can use the relative addressing scheme to, instead of absolute addressing scheme, to find the database. Here we are just creating the database. Some database for other projects are already here. So we will keep the collections name as beer kg one shot, and then metadata, we don't have any metadata, so just randomly use the cosine. Now the next part is we have knowledge graph triplets like kg triplets. So for each triplets, we will convert each triplets into plain text like triplet to text, and then we will embed each of those knowledge graph triplets and append to the collections. So then it will go and store into the vector DB. After that, we have a question like how polar bear's body looks. So in that case, we have a one short context, like the polar bear is a large bear native to the Arctic and nearby areas. So that context we are providing with this concept. So how to provide this context? So we will augment that text, like, so our one short context and then \n and then prompt. So we augmented both things. Now the next process is same. Just to consider this as a prompt, like a rich prompt, and then replace your old process like you did earlier. So after that, just apply the augmented text, apply the embedding for that. Use the same embedding model, sorry, and then apply the query like I did here to get the most similar information from your collections. So we decided to collect 4 similar informations, print the result. So means what informations we collected. from the knowledge graph triplets, which is, according to the system, shows that very similar to the our prompt or query. After that, we just appended each of those results for knowledge graph triplets one after another, separated by space. So this is a space related separations. So after that, the system is very simple. Like so the data is our results or knowledge graph triplets, four knowledge graph triplets, that is very much similar to our augmented text that we collected from our vector db. And then with respect to this data, we have some augmented text which contains one short example plus prompt, and then we will file this to llama 3 to get the answer. So just to run this and see what happens. This way you can develop a few short, two short, three short, like it depends upon you. And this is just a simple architecture. So I feel that you are clever enough to develop a more complex and better better pipeline on the top of this. I think within a few seconds we got the result in just a 16-bit, 16 GB RAM system. So what the four results in, what are the four similar query with respect to our prompt. So these are: modern bears have long snouts, modern bears have small rounded ears, modern bears have stocky legs, more bears have found in northern hemisphere, like that. So these kind of informations, knowledge graph triplets, it extracted with this is these are the similarity scores, cosine similarity scores. So these are the cosine similarity scores, and based on that it identified, according to the given information, modern bears means physical appearance, like that. So based on the given information, based on the means extracted knowledge graph triplets and given extra informations, it identifies that polar bear has a robust body with distinctive features. It long snouts, prominent part of the facial structure. It helps it sniff out seals and other prey in Arctic environment. Its fur is white, perfectly adapted to the blend in with the its fur is white, perfectly adapt to blend in with the snow and ice, allowing it to stalk and spray undetected. Means it looks like it has given the amazing answer with respect to the zero shot case. In just giving a one clue, it highly updated the quality of answers. So one shot is really amazing. So I think now I will do a lot of experiments and improve this. I hope you have enjoyed this tutorial. So thanks for watching.